to you.
All right, thank you so much. So it might take a minute or so for the platform to load up here, but I can kick things off and give you an intro to what we're planning to deliver for the National Space Power Center. So first of all, Sir General Saltzman, thank you so much for taking the time. Generals, everybody else who's taking a look here. We are really humbled to be working with HIPPY and the SFA to put together a capability that really extends and leverages a lot of what we've been building for Space Force and other customers, and puts it to work in kind of the ideal context as part of a collaborative environment focused on the mission, focused on delivering value, and supporting test, training, planning, full life cycle applicability for something unique and really digital first. So thank you again to HIPPY for having the vision to include us here, and once this thing loads up, we'll dive into a couple of vignettes. Just bring up the breakdown here. So while that keeps coming up, okay, there we go. Now you got something cool to look at. I'll just say I'm Robbie Robertson again with Sedaro. We've been working on this concept, and we've been focused specifically on what our technology, our enterprise cloud software platform applies to, which is what a digital platform should look like that can help drive that message forward about why space matters, and do it in a really adaptable, incrementally deliverable and holistic way, where we can map a common digital fabric of modeling and simulation assets, our own that are built natively within our platform that you can see here, but also third-party capabilities and content. So something really open and collaborative in the way it's structured, and meant to bring those things together and communicate why space matters, in addition to supporting those professionals who want to do the planning, the training, and the testing. So in the next few minutes, we'll show 3 short vignettes on this display. The first one's already up here. And actually, we've cut that to 2 to keep some focus on things we think will be particularly space power oriented and interesting to you guys. Each one is built from open source, unclassified data, by necessity to show in this environment, but also because the point we want you to take home is not exactly what we're modeling and simulating in the deep details, but really how much of a high fidelity holistic picture we can put together and then communicate in specific and differentiated ways for different potential stakeholders and consumers of that information. Everyone's going to have a different perspective that's going to be effective in supporting that test, training, planning. Also a different perspective that you're going to need to adapt, kind of the app layer for the sim capability and dial it in for to hammer home the messaging that you want to communicate. So the point is really just to demonstrate how quickly we built this, both of these mission threads, a third one as well, in just 2 weeks leading up to this event. And we're not talking, just the pictures you're used to seeing. It might be something like that, but an underlying physics-based simulation, physics and logic-based, that's capturing a truly holistic picture. So not just the orbit level dynamics, but also the human behaviors on the ground, the machine behaviors in space, that all have to work together to support an overall architecture executing the mission. And inside of each vehicle, full fidelity, full up physics-based simulation of all the subsystems and components at whatever appropriate level of fidelity is needed to really give you that holistic picture and be authoritative. So the platform is a cloud-native sim environment. It lets you move up and down in those levels of detail, go from the kind of executive view of what is this, why does it matter, all the way down to that kind of deep, detailed view for someone like the operator or the designer of a vehicle. So the vignettes that we put together will focus on situations that I think most effectively communicate space as a warfighting domain and the importance of space. So ones where the decision loop for Guardians needs to be more connected and faster, starting with this mission threat. So I'll just dive into it here. It's a co-orbital threat in GEO. Over here we've got, starting in the middle, more of the mission planner architecture level view. It's a SATCOM system, and the mission thread that is being potentially disrupted by a co-orbital threat in GEO is focused on delivering comm service from CONUS, from Schriever, to a ship in the South China Sea. And nominally, we're closing the loop with our GEO assets. So we've got AEHF and UFO and all the GEO monolithic assets out there is the nominal path for a certain type of communications. And then the important wrinkle and the one that's driving that need for connectivity between these different perspectives is the threat. So over here we've got like SITREP analytics oriented towards an intel analyst. You're trying to communicate that you've got this co-orbital threat. There's some dynamics and some maneuvering that's happening out there, driven by the actual delta V and internal subsystem intelligence that we have on a potential red threat. And then we're seeing the kind of reaction of that from the mission planner perspective, looking at their blue architecture network mapping and how they might be able to respond and work around our threatened asset, schedules, possible communication routes for all the different capabilities. And then, excuse me, over here, looking at that kind of operator level in the deeper details. So we're not trying to drown you with the RF math and all the underlying perspectives of someone designing the RF analysis, but what you care about. So what radio is active? Is it KA? Or are we falling back to the link 16? And do we have link margin? And we're simulating this with technical details about the transmitters and receivers on every vehicle, how they're pointed, where they're located, even what the weather is doing at the time of the simulation. So able to simulate the threat, see those dynamics, communicate them, communicate the potential for dynamic interaction between the threat and our GEO asset, showing off the options to reroute through the T1 transport layer in LEO, and leverage a Link 16 capability to deliver that essential connection to the ship in the South China Sea. So now we will we'll move along to the next mission thread, the next vignette here, and this one focuses on something maybe slightly more traditional and less dynamic, but increasingly complex if we want to really wring all the value that we potentially can out of the large quantity of proliferated assets that we're increasingly getting access to with proliferated LEO capabilities, both on the DoD side and commercial. But we're looking at a GMTI mission thread. And the different perspectives are still split in thirds here. We've got more of the, looking at the target deck and more like kind of the customer perspective for that imagery. On the left side, target deck schedule, when to image different locations, heat map that gets continuously updated based on our collect planning. And then in the middle, the vehicle level view. So showing what we can do and have done, not just for one vehicle supporting a mission like this, but we've done this for 500, 700 vehicles. Full fidelity, multi-physics simulation of every single agent in the simulation, and not something that takes you months to build up. It takes hours to build up a simulation like that when you have the collection assets to bring into this scalable collaborative platform. But we're looking at power generation, the solar panels, driven by how the vehicle is being tasked to point. We've got power flow through the system, so from your solar panels through your power system out to thermal, and then even pointing error down here. All these dynamics are connected together. When you tell a satellite to image a location, it turns, the solar rays get illuminated differently, the heat's distributed differently, your control systems all change state. When you spin up a reaction wheel or fire a thruster, you consume power, and we see that dependency. You can see some of the loads on the power system jumping around. So we can use this as a teaching tool, as a tool to kind of point out how there's direct connectivity between what you can get on the imaging and GMTI mission side of things, and how it's based on and constrained by what the vehicles can do, and draw that connection in a common environment. And then finally, on the far left here, synthetic imagery that we can integrate with maybe capabilities from that imaging payload vendor to provide alongside the other, more traditional mission planning assets, and some dynamic analytics on where we have imaging access today. But all of this is just an example of the kind of diversity of analytics and perspectives that we can try and put together in a few weeks. We're ready to get after it with Hippie and the team at SFA and the entire community that's plugged in there to contribute, and both at the unclass level, but higher classifications as well. We're supporting customers. We are exceptionally open and adaptable. I think from a business model perspective, that's what we've emphasized. That's what's been really required for us to succeed over the 6 years of the company, and the cloud scalability, the level of holistic simulation that we can deliver efficiently is driven by the tech, but really our company culture and our business model is built to be open and collaborative and get shots on goal and deliver value however we can. If we can leverage work that we're doing elsewhere in service of the NSC mission, we're excited to do it, and thanks again for the opportunity to share with you guys.
And are you on contract right now?
Yes. Yeah, we're on contract with SDA, with an IC customer. We have an AFRL IDIQ. SSC, we've supported test and evaluation, training, wargaming, everything full life cycle from mission engineering to mission ops. Really excited with SWAC and OTTI and SSIO working for Woody and delivering a prototype for a holistic mission engineering capability that integrates across all the PDOs. So really excited to see where that's going, and really complementary, I think, to what you're getting after with NSC.
Exactly.